यामध्ये आपण बघणार आहोत तीन थिरम्स, रोल्स थिरम्स, लॅग्रेंजस मीन व्हॅल्यू थिरम आणि कॉचीज मीन व्हॅल्यू थिरम. नाउ वी फर्स्ट स्टार्ट रोल्स थिरम. Let f of xy be a function defined on closed interval ab such that f of x is continuous on closed interval ab, f of x is differentiable on open interval ab, and f of a is equal to f of b. Then there exists c belongs to open interval ab such that f dash c means derivative of f of x at c is equal to 0. This is a Rolle's theorem. There are three conditions. What is the first condition? First condition is f of x should be continuous in the closed interval AB. F of x is differentiable in open interval AB. That is the f of x is differentiable at every point belonging to open interval AB. Also, f of a is equal to f of b. Then there exists c belongs to open interval AB such that f dash c is equal to 0. Now we have to verify the Rolle's theorem for this function f of x is equal to x square minus 6x plus 5 in the closed interval 1 to 5. Okay. Now here what is given? Given that f of x is nothing but this function x square minus 6x plus 5. Okay. Now this is the expression. This is an algebraic function, so it is a always continue on any closed interval. So first condition is obvious, that is f of x is continuous on closed interval 1 to 5. Now what about the derivative? Find out the derivative of this f of x. F of x is nothing but x square minus 6x plus 5. Take the derivative. Derivative of x square is 2x, and derivative of minus 6x is minus 6, and a derivative of 5 is 0 because it's a constant. So what's the derivative? F dash x is nothing but 2x minus 6. So f dash x is exists. So f of x is differentiable on open interval 1 to 5. Now what about f of a and f of b? So what is a is here? A is 1 and b is 5. So f of a is equal to, that's a is nothing but 1. So f of 1 is equal to, put x is equal to 1 in this expression, that is 1 square minus 6 into 1 plus 5. There's a 1 square is 1, 6 into 1 is 6 plus 5. So 1 plus 5 is 6 minus 6, that is 0. So f of 1 is equal to 0. Similarly, what about f of 5? Here we replace x by 5. So 5 square minus 6 into 5 plus 5. So this is 5 square is 25 plus 5, that is 30, minus 30, that is 0. So here we get f of 1 is equal to f of 5, that is f of a is equal to f of b. So all the three conditions of Rolle's theorems are satisfied. So by using Rolle's theorem, there exists c belongs to open interval 1 to 5 such that f dash c is equal to 0. So but we have already find a f dash c. F dash c is nothing but this 2x minus 6. So here we can replace this 2x minus c, that is nothing but 2c. 2x minus c, this is f dash x, but here x is replaced by c, so 2c minus 6 is equal to 0. So take this 6 in this side, so in this side this is minus, इकडे येताना तो प्लस होईल. सो 2c is equal to 6. हा 2 इकडे येताना मल्टिप्लायला आहे, इकडे येताना तो डिवाइडला होईल. सो 6 by 2, that is c is equal to 3. And clearly this 3 belongs to this open interval 1 to 5. हा 1 to 5 च्या मध्ये. So Rolle's theorem is verified. Now verify the Rolle's theorem for f of x is equal to sin x in the closed interval 0 to pi. Let what is given? Given that f of x is equal to sin x. This is a given function. Clearly this continuous on closed interval 0 to pi. F of x is continuous on closed interval 0 to pi. What about the derivative? Derivative of sin x is cos x. So f dash x is exists. So f of x is differentiable on open interval 0 to pi. What about the f of a and f of b? If a is here 0. So f of a is nothing but f of 0. Sin 0. Sin 0 is nothing but 0. So f of a is equal to 0. What about f of b? If b is nothing but here pi. So f of pi, that is sin pi. Sin pi is again 0. So f of a is equal to f of b. So all the three conditions of Rolle's theorem are satisfied. So by using Rolle's theorem, there exists C belongs to open interval 0 to pi such that f dash C is equal to 0. So what is the f dash C? F dash x is nothing but cos pi. Sorry, cos x. So f dash C is cos C. So here we get cos C is equal to 0. And in the what value of C we get cos C is equal to 0. So the value of C must be plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, and so on. Okay, but only with the value C is equal to pi by 2 lies between 0 to 2 pi. Sorry, 0 to pi. So C is equal to pi by 2 belongs to open interval 0 to pi. So hence the Rolle's theorem verified. Now, third example, verify the Rolle's theorem for f of x is equal to sin x upon e raised to x in the closed interval 0 to pi. Similarly, as above, this is a given function f of x is equal to sin x upon e raised to x. We observe that f of x is continuous on closed interval 0 to pi. Let f of x is equal to sin x upon e raised to x. We have to find the derivative of this function. So f dash x is equal to e raised to x. So here we have to use u upon v rule. There's a v into derivative of u. Derivative of u here u is nothing but sin x. Derivative of sin x is cos x minus u, that is the sin x, into derivative of e raised to x is e raised to x upon v square, that is e raised to x bracket square. So we can take e raised to x common from numerator and cancel with the denominator. So we get here cos x minus sin x upon e raised to x. That is f dash x is nothing but cos x minus sin x upon e raised to x. So f dash x is exists. So f of x is differentiable on open interval 0 to pi. Now f of a is nothing but f of 0. So sin 0 upon e raised to 0. Sin 0 is 0 and e raised to 0 is 1. 0 upon 1 is 0. So that's the here we get f of 0 is 0. What about the f of pi? F of pi is sin pi upon e raised to pi. Clearly sin pi is 0 and e raised to pi is any value. So 0 upon e raised to pi is nothing but 0. So we get here f of pi is again 0, f of 0 is again 0. So we get f of 0 is equal to f of pi, that is f of a is equal to f of b. So all the three conditions of Rolle's theorems are satisfied. So by using Rolle's theorem, there exists c belongs to 0 to pi such that f dash c is equal to 0. So put the value uh, in f dash of x as x is equal to c. So we get e raised to c cos c minus sin c into e raised to c upon e raised to c bracket square. So we can take the e raised to c common and cancel. So we get cos c minus c sin c upon e raised to c. आणि हा e raised to c divide ला इकडे जातो तो multiply होईल 0 into e raised to c is 0. So we get just only cos c minus c is equal to 0. So cos c is equal to sin c. आणि अशी कोणती व्हॅल्यू आहे की ज्याला दोघं व्हॅल्यू कोइन्साइड होतात, दॅट इज नथिंग बट पाय बाय 4. सो सी इज इक्वल टू पाय बाय 4 belongs to open interval 0 to pi. So hence Rolle's theorem verified. Now the fourth example, verify the Rolle's theorem for f of x is equal to x minus a raised to m and x minus b raised to n on the open closed interval ab. This is the given function f of x is equal to x minus a raised to m and x minus b raised to n. Clearly, this is a continuous on closed interval ab. What about the f dash of x? We have to find a derivative of this. That u into v rule. Use the u into v rule. This is our u and this is our v. So u into derivative of v. The u is nothing but x minus a raised to m into n into x raised to x minus b raised to n minus 1 plus b into derivative of v, derivative of u, that is m into x minus b raised to m minus 1. So f dash of x exists. So f of x is differentiable on open interval ab. Now f of a is nothing but here if we put a x is equal to a, then we get a minus a is 0. So f of a is 0. Similarly f of b is equal to 0. So f of a is equal to f of b. So f of x satisfies all the three conditions of Rolle's theorem. So by using Rolle's theorem, there exists c belongs to open interval ab such that f dash c is equal to 0. Put c is equal to x is equal to c in f dash of x. So we get this, and by solving we get c minus a is equal to 0 or c minus b is equal to 0. So that is c is equal to a or c is equal to b. or third condition nc minus na plus mc minus mb is equal to 0. So here we get nc plus mc minus mb plus na is equal to 0. We can take c as a common, so c into n plus m is equal to mb plus na. Here this n plus m multiply like another divide level, so c is equal to mb plus na upon n plus n belongs to open interval ab, because c is equal to a not belongs to open interval ab and c is equal to b not belongs to open interval ab. So this shows that the Rolle's theorem is satisfies for this function also. Okay, now the example fifth, verify the Rolle's theorem for f of x is equal to log of x square plus ab upon a plus b into x on closed interval ab. Similarly as above, f of x is this is given function, and f of x is continuous on closed interval ab. This is f of x. We have to find out the derivative of this. What is the derivative of f of x? Derivative of f of x is log of, now we have to find a derivative of this. So this is log of m plus n, log of m plus log of m upon n. Log of m upon n can be written as log m minus log n. So here we can separate log of x square plus ab minus log of a plus b into x. Now we have, it is easy to find the derivative of this function. Derivative of log of function is nothing but 1 upon, that is a 1 upon x square plus ab into derivative of this, that is 2x. Again this is again 1 upon a plus b into x into derivative of this is nothing but a plus b. So this a plus b gets cancelled. So we get the f dash x is nothing but 2x upon x square plus ab minus 1 upon x. This is our f dash of x. So f of x is differentiable on open interval ab. Now we have to find f of a. So put x is equal to a. So log of a square plus ab upon a plus b into a. So in the numerator it's a square plus ab, so in the denominator is x square a square plus ab. So a square plus ab, a square plus ab gets cancelled, so we get log of 1, and log of 1 is equal to 0. Similarly, if we put f of x is equal to b in f of x, so we get again log 1 is equal to 0, so we get f of a is equal to f of b. So all the three conditions of Rolle's theorem are satisfied. So by using Rolle's theorem, there exists c belongs to open interval ab such that f dash c is equal to 0. So put here x is equal to c in f dash of x, so 2c upon c square plus ab minus 1 upon c is equal to 0. Take this 1 upon c, or take the cross multiplication. If you put take the cross multiplication to then 2c square mm, minus c square minus ab is equal to 0. Okay, and denominator gets cancelled with 0 by taking in this side. So we get 2c square minus c square plus ab is equal to 0. Here we can take 2c square minus c square is nothing but c square minus ab is equal to 0. So c square is equal to ab. So c is equal to plus or minus of root ab. So in from these two values, plus root ab is belongs to open interval ab, and minus root ab is not belongs to open interval ab. So here there exists some number c is equal to root ab belongs to open interval ab, hence the Rolle's theorem verified. Now the last example, verify the Rolle's theorem for f of x is equal to e raised to x into sin x minus cos x in the pi closed interval pi by 4 minus 5 pi by 4. Similarly, as above, f of x is continuous, find out derivative, that is the 2 e raised to x sin x, and if dash x is exists, so if dash f of x is differentiable in this open interval, find out f of a, then we get this is 0, f of b is again 0. So f of a is equal to f of b. Hence f of a satisfies all the conditions of Rolle's theorem. So by using Rolle's theorem, there exists c belongs to open interval pi by 4 minus 5 pi by 4 such that f dash c is equal to 0. Put the values in f dash x is replaced by c. So 2 e raised to c sin c is equal to 0. 2 e raised to c multiply like इकडे divide like 0 into 0 divided by 2 e raised to c is nothing but 0. So we get sin c is equal to 0. So what is the value of c? C is nothing but 0 plus or minus pi plus or minus 2 pi and so on. From out of this, only pi, c is equal to pi lies between this open interval pi by 4 and minus pi by 4. In the next theorem, in the next lecture, we have to see the Lagrange's mean value theorem. पुढच्या लेक्चरला आपण Lagrange's mean value theorem बघूया. Thank you.